Alright guys, in this video, we're going to go over and do a few examples of the angle-angle similarity theorem, the side-angle-side similarity theorem, and the side-side-side similarity theorem. So, just three more examples. It'll be short and sweet and won't take very long. Alright, so if we look at this first one on the top, it says an equilateral triangle. Okay, remember equilateral means all sides are equal. Okay, has a side length of 5 inches. So I'm just going to go ahead and draw that. Okay, so here's an equilateral triangle, 5, 5, 5. Okay, and another equilateral triangle, so this one's also equilateral triangle, so all sides are equal, has a side length of 10 inches. So here's 10, here's 10, here's 10. Okay, are the triangles similar? Well, guys, if we I don't know, let's highlight corresponding parts. Well, they're all kind of corresponding to each other, but let's pretend they're not. So I'll highlight this last side, blue on each of them. Ooh. Alright, so if I set proportions, so I can say 5 is to 10. 5 over 10, that equals 1/2. Okay. Another 5 over 10, that equals 1/2. And another 5 over 10, that equals 1/2. So because all these are the same, I can say yes, these triangles are similar by the side-side-side similarity theorem. Okay, now another thing you could have done is, if you remember back from chapter 4, I believe, when we learned that if a triangle is equilateral, it's also equiangular. Okay, so all these are 60 degrees. Same thing over here. All these are 60 degrees. You could have also said these triangles are similar by the angle-angle similarity theorem. Okay. So yes, these are similar by a scale factor of 1/2. Or if you flipped that and put 2 over 1, that would be okay too. Alright, so let's look in the middle example of this page. Okay, it says write a similar statement for any similar triangles. Okay, so if I were to draw this triangle on the left, or highlight this triangle on the left, okay, well, if this is 90, guys, this also has to be 90. And if this is 50, 50 plus 90 plus 40 is equal to 180. Okay, now I'm going to take a look at this triangle over here. Okay, so I have a 90, I have a 40, and if I were to subtract those from 180, this would have to be 50. Okay, and then if I look at this big triangle, I have, this is 50, this is 90, and this is 40. So all of these triangles have angle measures of 40 degrees, 50 degrees, and 90 degrees. Okay? Therefore, all are similar by the angle-angle similarity theorem. All right, now let's write a similarity statement. So I'm going to say triangle CAT. So I always start with the big triangles. You don't have to, but I do. And when I do triangle CAT, that's this big triangle here, my angle C is 50 degrees, my A is 40 degrees, and then my angle T is 90 degrees. Okay, so the next triangles that I have to put out here have to go in that order as well. So I'm going to look back to my yellow triangle. Okay, my 50-degree angle was C. my 40-degree angle was up here at T, and my 90-degree angle was right here at R. Okay, and that's going to be similar to triangle. Okay, now I'm going to do this one on the right here. So once again, I go back to 50, which is right here at T. Next, I turn on my 40-degree angle, which is right here at A. And then my 90-degree angle is right here at R. All right, guys, let's look at this third and final problem on this. It says the two triangles are similar. And because they're similar, I'm going to go ahead and highlight the corresponding sides to where the corresponding sides have the same colors. Okay. Now I want to find X and Y. So I'm going to put find X over here, find Y over here. All right, when I look at these triangles, if I look at these sides highlighted in blue, I notice that they have side lengths given. They don't have any variables in them. So I'm going to use that to our advantage. Okay, so I'm going to say 4 is to 10 as, I'm going to solve for X here, X minus 3 is to 20. Okay, I want to cross multiply. Now remember, when I cross multiply, this here has to go into parentheses. Okay, so I get 4 times 20 equals 10 parentheses X minus 3. And now because this is in parentheses, we have to distribute. So 4 times 20 is 80 equals 10x minus 30. Add 30 to both sides. I get 110 equals 10x, divide by 10. X then has to equal 11. Alright, now I want you to go ahead and find Y on your own, and then we'll go over. Alright, so when we find Y, once again, we're still going to use this 4 over 10. So 4 over 10 equals, so the triangle on the left is on top, triangle right's on bottom, so this 10 is going to be on top, over 2y plus 3 is going to be on bottom. Okay, and if I cross multiply, remember when I do that, this here goes in parentheses, so I am left with 4 times 2y plus 3 equals 10 times 10. Okay, because this is in parentheses, I have to distribute this through. So 8y plus 12 equals 10 times 10 is 100. Okay, so if I subtract 12 from both sides, I get 8y equals 88. Divide by 8, I get y is also 11. And that's how you find your x and your y.